In school, your physics teacher will eventually teach you the conservation of energy. The idea behind it is that the loss in potential energy gets converted into kinetic energy. So let me try and illustrate what's going on here. So kinetic energy is the energy associated with anything that's moving. So for example, if you have a car that weighs, let's imagine 5 kilograms, traveling at 2 meters per second. So the kinetic energy here, the kinetic energy of this car is, well, you would put 5 into the m, so a half times 5 times v squared. V is the velocity, 2 squared. So this will be 4 times 5 will be 20, divided by 2, that will be 10. So this 10 is the amount of energy associated with something that's moving. This kinetic energy has the potential to do something. For example, it could smash down a wall. So it has some sort of energy associated with something that's moving. Now, potential energy, imagine you've got a brick up here and then you're about to drop it, but you haven't dropped it yet. That brick there has the potential to do something. It has a potential to smash someone's head. It has a potential to do things. It has some energy stored in that brick. So imagine you've got a brick that weighs, let's say, 2 kilograms. The potential energy would be the mass of the brick times gravity. So hang on. So the potential energy of this brick that weighs 2 kilograms is given by m, which is the mass of the brick, 2, times gravity, which is 10, and then times the height from the ground up to here. In this case, it's 80 meters. So that would be 160 with a 0. So the potential energy associated with this brick is this number here. Now, when you drop that brick, just before it hits the ground, it's traveling really fast. Now, this brick has kinetic energy because it's moving. So the kinetic energy here is a half times the mass of the brick, which is 2, times the velocity. We don't know the velocity. I'm trying to calculate the velocity, times v squared. So that would be, kinetic energy, half times 2 would be 1, times v squared, that would be v squared. So what that means is the potential energy is this number here. By the time it hits the ground, the potential energy would be 0. There is no stored energy anymore because it hits the ground. Everything has been converted into kinetic energy. So if you want to know the velocity, you set this to be the same as the kinetic energy. So that would mean set these two to be the same. So let's set the two to be the same, because the loss in potential energy gets converted into kinetic energy. So kinetic energy is v squared. So if you want to know the velocity, it would be the square root of this thing here. So the velocity would be the square root of that thing, which would be 40. Now remember, we've done this many times. Remember that formula, hgt squared over 2 and so on. If you were to drop a brick, because we're on Earth, gravity is 10, the acceleration of 10. That means when t is 1, the velocity is 10. When t is 2, the velocity is 20. When t is 3, the velocity will be 30. When t is 4, the velocity is 40. So everything tallies up. If you view things from the perspective of anything that's free falling, 10, 20, 30, 40. So the velocity here is 40. Now let's view it from the perspective of potential energy converting to kinetic energy. You would come to the same conclusion. The velocity here is also 40. So the conservation of energy is any potential energy gets converted into kinetic energy. So the loss in potential energy gets converted into kinetic energy. So the two tallies up, okay?